Audio-video engineering MCQs. Multiple choice questions. Audio-video engineering MCQs, multiple choice questions, with answers. 1. The intensity of a sound wave is measured by its A. Frequency, B. Wavelength, C. Amplitude, D. Phase. Answer: C. Amplitude. Explanation: the amplitude of a sound wave is the maximum displacement of vibrating particles in a medium from their mean position when the sound is produced. The intensity or strength of a sound wave is measured by its amplitude. 2. What is a measurement unit of intensity of a sound wave? A. Hertz, B. Radians, C. Fon, D. Decibels. Answer: D. Decibels. Explanation: decibels, dB, are a measurement unit of the intensity of a sound wave. It normally measures sound pressure level. Human hearing has a lower threshold of 0 dB at 1 kHz. Sound amplitude may be determined using the following formula: amplitude, dB, equals 20 logs 10. 3. What is the relation between wavelength and frequency? A. High-frequency sounds have shorter wavelengths. B. High-frequency sounds have larger wavelengths. C. Low-frequency sounds have shorter wavelengths. D. None of the above mentioned. Answer: A. High-frequency sounds have shorter wavelengths. Explanation: the wavelength of a wave is inversely proportional to its frequency. High-frequency sounds have shorter wavelengths. 4. The position of a sound wave to a reference point is referred to as A. Frequency, B. Wavelength, C. Amplitude, D. Phase. Answer: D. Phase. Explanation: the position of a sound wave to a reference point is referred to as its phase. 5. Sound waves are also known as A. Matter wave, B. Mechanical wave, C. Transverse wave, D. Microwave. Answer: B. Mechanical wave. Explanation: sound waves are also known as mechanical waves. Mechanical waves are waves that require a medium, solid, liquid, or gas, to travel through. In the case of sound waves, they are produced by the vibrations of particles in a medium, which then propagates as compressions and rarefactions through the medium. 6. Amongst which of the following determines sound's pitch? A. Phase, B. Wavelength, C. Amplitude, D. Frequency. Answer: D. Frequency. Explanation: frequency determines the sound's pitch. The pitch of a sound refers to how high or low it sounds to a person's ear. The pitch is closely related to the frequency of the sound wave. 7. In sound waves, diffraction occurs due to A. Encounter obstacles. B. Pass through openings similar in size to their wavelength. C. Both A and B. D. Diffraction. Answer: D. Diffraction. Explanation: when sound waves encounter obstacles or pass through openings similar in size to their wavelength, they bend or spread out. This phenomenon is known as diffraction. 8. In sound waves, the degree of diffraction is proportional to A. The wavelength of the sound. B. The size of the obstruction. C. Both A and B. D. None of the mentioned above. Answer: B. The size of the obstruction. Explanation: the degree of diffraction is proportional to the size of the obstruction. In sound waves, the degree of diffraction is proportional to the wavelength of the sound waves and the size of the obstacle or opening that the sound waves encounter. 9. Amongst which of the following refers to modifying the difference between the softest and loudest parts of a sound wave? A. Dynamic effect, B. Domino effect, C. Spectrum effect, D. Modulation effect. Answer: A. Dynamic effect. Explanation: dynamic effect refers to modifying the difference between the softest and loudest parts of a sound wave. 10. In sound waves, d is the amount of time required for one complete cycle of vibration to occur. A. Speed b, period c, phase d, interval. Answer, b, period. Explanation, the period is the amount of time required for one complete cycle of vibration to occur. The period is related to the frequency of the sound wave, which is the number of cycles per second, or Hertz Hc. The period and frequency are inversely related, meaning that as the period increases, the frequency decreases, and vice versa. 11. Amongst which of the following shows the relation between period and frequency? A. Period and frequency are directly related to each other. B. Period and frequency are inversely related to each other. C. Period and frequency have no relation. D. None of the mentioned above. Answer, B. Period and frequency are inversely related to each other. Explanation, period and frequency are inversely proportional to one another. The period of a sound wave refers to the time it takes for one complete cycle of the wave to occur. It is usually measured in seconds. The frequency, on the other hand, is the number of cycles of the wave that occur in 1 second and is measured in Hertz Hc. 12. The magnitude or amplitude of a sound wave at a certain place in space is represented by A. Sound pressure. B. Sound intensity. C. Sound energy. D. None of the mentioned above. Answer, A. Sound pressure. Explanation, the magnitude or amplitude of a sound wave at a certain place in space is represented by sound pressure. 13. Sound power level is expressed in A. Hertz. B. Radians. C. Fon. D. Decibels. Answer, D. Decibels. Explanation, sound power level is expressed in decibels. 14. Sound intensity is commonly measured in A. Hertz. B. Watt per square meter. C. Fon. D. Decibels. Answer, D. Decibels. Explanation, the unit for sound intensity level in decibels, dB. 15. What do the higher sound pressure readings suggest? A. It suggests that sound waves are stronger or louder. B. It suggests that sound waves are weak. Answer, A. It suggests that sound waves are stronger or louder. Explanation, higher sound pressure readings suggest that sound waves are stronger or louder. 16. Sound pressure is proportional to which of the following? A. Sound intensity. B. Sound velocity. C. Sound energy. D. None of the mentioned above. Answer, A. Sound intensity. Explanation, sound pressure is directly proportional to sound intensity. 17. Amongst which of the following component captures sound in the environment? A. Tympanic membrane. B. Ossicles. C. Pinna. D. None of the mentioned above. Answer, C. Pinna. Explanation, pinna is the external ear that aids us to capture sound in the environment. The pinna's distinct form and structure enable it to gather sound waves from its surroundings. As sound waves move through the air, they collide with the pinna's curves and ridges. This contact alters the incoming sound waves, allowing the pinna to selectively amplify or attenuate certain frequencies. 18. Sound waves go from the pinna to the middle ear via which tube-like structure? A. Tympanic membrane. B. Ossicles. C. Eustachian tube. D. Ear canal. Answer, D. Ear canal. Explanation, sound waves go from the pinna to the middle ear via an ear canal tube-like structure. 19. Which of the following structures converts sound waves into electrical signals? A. Tympanic membrane. B. Ossicles. C. Eustachian tube. D. Cochlea. Answer, D. Cochlea. Explanation, cochlea structures convert sound waves into electrical signals. 20. Sound vibrations, transmitted and amplified from the eardrum to the inner ear through A. Tympanic membrane. B. Ossicles. C. Eustachian tube. D. Vestibular system. Answer: B. Ossicles. Explanation: sound vibrations are transmitted and amplified from the eardrum to the inner ear through the ossicles component. 21. An is a higher frequency that accompanies the fundamental frequency. A. Pitch. B. Velocity. C. Timbre. D. Overtone. Answer: D. Overtone. Explanation: an overtone is a higher frequency that accompanies the fundamental frequency. Overtones, also known as harmonics, are frequencies that occur in addition to the fundamental frequency of a vibrating item. When an item vibrates, the fundamental frequency, which is the lowest and loudest pitch, is principally produced. 22. Sound vibrations refer to the mechanical oscillations that propagate through a medium, such as air, water, or solids. A. True. B. False. Answer: A. True. Explanation: sound vibrations are mechanical oscillations or motions that propagate across a medium, such as air, water, or solids, and allow sound waves to be transmitted. 23. The feature of a sound that differentiates it from others is referred to as its A. Pitch. B. Velocity. C. Timbre. D. Overtone. Answer: C. Timbre. Explanation: the feature of a sound that differentiates it from others is referred to as its timbre. Timbre refers to the characteristic sound quality or tone of a musical note, sound, or instrument. 24. How many types of overtones? A. 5. B. 4. C. 3. D. 2. Answer: D. 2. Explanation: there are two types of overtones, names harmonic overtones and inharmonic overtones. 25. Amongst which of the following overtones are generally known as natural overtones? A. Harmonic overtones. B. Inharmonic overtones. C. Both A and B. D. None of the mentioned. Answer: A. Harmonic overtones. Explanation: harmonic overtones are generally known as natural overtones. These are the frequencies that are integer multiples of the fundamental frequency of a vibrating object. 26. Which of the following is not an example of a harmonic overtone? A. Guitar. B. Flute. C. Bell. D. Trumpet. Answer: C. Bell. Explanation: bell is an example of a harmonic overtone. 27. Are the frequency ratio distances between two pitches or sounds? A. Phase. B. Intervals. C. Period. D. Octaves. Answer: B. Intervals. Explanation: intervals are the frequency ratio distances between two pitches or sounds. 28. Amongst which of the following influences reverberation? A. Diffusion. B. Amplitude. C. Refraction. D. Diffraction. Answer: A. Diffusion. Explanation: reverberation is the phenomenon of sound persisting after it has been stopped owing to repeated reflections off surfaces within a closed surface, such as furniture, people, air, and so on. Reverberation is influenced by the diffusion of sound waves. 29. A microphone's polar pattern determines its to sound from various directions. A. Distortion. B. Directivity. C. Sensitivity. D. None of the mentioned. Answer: C. Sensitivity. Explanation: a microphone's polar pattern determines its sensitivity to sound from various directions. 30. The capacity of a microphone to convert sound into an electrical signal is known as A. Distortion. B. Directivity. C. Sensitivity. D. None of the mentioned. Answer: C. Sensitivity. Explanation: the capacity of a microphone to convert sound into an electrical signal is referred to as sensitivity. 31. SNR stands for A. Sensitivity noise ratio. B. Signal noise ratio. C. System noise ratio. D. Signal to noise ratio. Answer: D. Signal to noise ratio. Explanation: SNR stands for signal to noise ratio. The signal-to-noise ratio, SNR, is a metric used in communication and measurement systems to quantify the amount of a desired signal in comparison to the level of background noise. It is the ratio of the signal's power or amplitude to the noise's power or amplitude. 32. A microphone's SNR should be to capture clean and clear audio with little noise interference. A. High. B. Low. C. Medium. D. None of the above mentioned. Answer: A. High. Explanation: a microphone's SNR should be high to capture clean and clear audio with little noise interference. 33. Amongst which of the following type of microphone collects sound from all directions equally? A. Omnidirectional. B. Cardioid. C. Dynamic. D. Shotgun. Answer: A. Omnidirectional. Explanation: an omnidirectional microphone collects sound from all directions equally. It is designed to capture sound from every angle around it. It is useful for situations where you want to record or capture audio from multiple sources or in a 360-degree environment. 34. Microphones respond best to sound coming from the front and less to sound coming from the sides and rear. A. Condenser. B. Cardioid. C. Dynamic. D. Shotgun. Answer: B. Cardioid. Explanation: cardioid microphones respond best to sound coming from the front and less to sound coming from the sides and rear. 35. Which of the following types of microphones is also known as pressure zone microphones? A. Lavalier microphones. B. Shotgun microphones. C. Ribbon microphones. D. Boundary microphones. Answer: D. Boundary microphones. Explanation: boundary microphones is also known as pressure zone microphone. It is designed to pick up sound with a unique polar pattern and acoustic characteristics. It is also known as a boundary microphone or a pressure plate microphone. 36. Dynamic microphones are based on which principle? A. Superposition. B. Electromagnetic induction. C. Electromagnetism. D. Wave-particle duality. Answer: B. Electromagnetic induction. Explanation: dynamic microphones work on electromagnetic induction. Electromagnetic induction is a phenomenon that occurs when a conductor is subjected to a changing magnetic field and induces an electric current in it. Electromagnetic induction is used by dynamic microphones to transform sound waves into electrical impulses. 37. Among dynamic microphones and condenser microphones, which is more sensitive and precise? A. Dynamic microphones. B. Condenser microphones. C. Both A and B. D. None of the above mentioned. Answer: B. Condenser microphones. Explanation: when compared to dynamic microphones, condenser microphones are more sensitive and precise. It is a type of microphone that converts sound waves into electrical signals using a capacitor. It's common in professional audio recording, broadcasting, and live sound reinforcement. 38. Shotguns microphones are microphones. A. Omnidirectional. B. Directional. C. Both A and B. D. None of the above mentioned. Answer: B. Directional. Explanation: shotguns microphones are directional microphones. 39. Which component in microphones is a thin, flexible membrane that responds to sound by vibrating? A. Transducer. B. Capsule. C. Diaphragm. D. Preamp. Answer: C. Diaphragm. Explanation: a diaphragm is a thin, flexible membrane that responds to sound by vibrating. 40. The component turns the diaphragm's mechanical vibrations into electrical impulses. A. Transducer. B. Capsule. C. Connector. D. Preamp. Answer: A. Transducer. Explanation: the transducer is the component that turns the diaphragm's mechanical vibrations into electrical impulses. 41. Which of the following microphones is resistant to moisture? A. Dynamic microphones. B. Condenser microphones. C. Capacitor microphones. D. Crystal microphone. Answer: D. Crystal microphone. Explanation: a crystal microphone is resistant to moisture. It is a type of microphone that uses the piezoelectric effect to transform sound waves into electrical impulses. The capacity of some materials to create an electric charge when subjected to mechanical stress or pressure is referred to as the piezoelectric effect. 42. The of a loudspeaker is a measurement of how well it transforms electrical power into sound output. A. Impedance. B. Sensitivity. C. Power handling. D. Frequency response. Answer: B. Sensitivity. Explanation: the sensitivity of a loudspeaker is a measurement of how well it transforms electrical power into sound output. A loudspeaker's sensitivity is a measure of its efficiency in converting electrical power into sound pressure level, SPL. It denotes how loud a speaker may get when powered by a specific quantity of power. 43. Loudspeakers' impedance is usually measured in A. Watts. B. Pascals. C. Fahm. D. Ohms. Answer: D. Ohms. Explanation: measuring the impedance of a loudspeaker typically involves using an impedance meter or an ohm meter. 44. Loudspeakers designed for the reproduction of low-frequency sounds, typically below 100 Hz, are known as A. Dynamic loudspeakers. B. Full-range loudspeakers. C. Subwoofers. D. Horn loudspeakers. Answer: C. Subwoofers. Explanation: loudspeakers designed for the reproduction of low-frequency sounds, typically below 100 Hz, are known as subwoofers. 45. In which type of loudspeaker, a thin, electrically charged diaphragm is positioned between two stator panels? A. Dynamic loudspeakers. B. Full-range loudspeakers. C. Electrostatic loudspeakers. D. Horn loudspeakers. Answer: C. Electrostatic loudspeakers. Explanation: a thin, electrically charged diaphragm is positioned between two stator panels in electrostatic loudspeakers. 46. Amongst which of the following types of directivities of loudspeakers are frequently employed where sound must be focused in a specific zone? A. Unidirectional. B. Omnidirectional. C. Bipolar. D. Horn-loaded. Answer: A. Unidirectional. Explanation: unidirectional speakers are frequently employed in circumstances where sound must be focused in a specific zone. 47. Loudspeakers emit sound both forward and backward. A. Unidirectional. B. Omnidirectional. C. Bipolar or dipolar. D. Horn-loaded. Answer: C. Bipolar or dipolar. Explanation: bipolar or dipolar loudspeakers emit sound in both forward and backward directions. These loudspeakers are designed for audio systems. They are known for their ability to create a more immersive soundstage and spaciousness compared to conventional monopole speakers. 48. Which of the following components in a loudspeaker is a protective cover positioned in the center of the diaphragm? A. Magnet assembly. B. Dust dome. C. Frame. D. The voice coil. Answer: B. Dust dome. Explanation: the dust cap, often known as the dust dome, is a protective cover positioned in the center of the diaphragm. 49. All the components of the loudspeaker are housed within the loudspeaker. A. Magnet assembly. B. Suspension system. C. Frame. D. The voice coil. Answer: C. Frame. Explanation: all the components of the loudspeaker are housed within the loudspeaker frame, also known as the chassis. 50. In a multi-way speaker system, the crossover network is made up of electrical components. A. Active electrical components. B. Passive electrical components. C. Both A and B. D. None of the mentioned above. Answer: B. Passive electrical components. Explanation: in a multi-way speaker system, the crossover network is made up of passive electrical components such as capacitors, inductors, and resistors. 51. The crossover network includes which of the following? A. HPF. B. LPF. C. BPF. D. All of the above mentioned. Answer: D. All of the above mentioned. Explanation: high-pass, low-pass, and band-pass filters are commonly used in crossover networks. It is a system that is used to divide an audio signal into different frequency bands and direct each band to the appropriate speaker or driver. 52. Optical recording uses storage media. A. Reel-to-reel audio tape. B. Cassette tape. C. Disc type. D. Betamax tape. Answer: C. Disc type. Explanation: optical recording uses disc-like storage media like compact discs, CDs. 53. An is a type of electrical device that boosts the loudness of an audio stream. A. Audio amplifier. B. Echo reverberation. C. Time reverberation. D. Acoustic reverberation. Answer: A. Audio amplifier. Explanation: an audio amplifier is a type of electrical device that boosts the loudness of an audio stream. 54. Analog to digital converters, ADCs, are used in disc-based recording to transform audio impulses into digital data. A. True. B. False. Answer: A. True. Explanation: analog to digital converters, ADCs, are used in disc-based recording to transform audio impulses into digital data. 55. Is the technique of collecting and presenting lines of an image or picture on a television screen in a sequential manner. A. Framing. B. Scanning. C. Flickering. D. Signaling. Answer: B. Scanning. Explanation: scanning is the technique of collecting and presenting lines of an image or picture on a television screen in a sequential manner. 56. Which of the following scanning methods is employed in the analog television system? A. Interlaced scanning. B. Progressive scanning. C. Both A and B. D. None of the above mentioned. Answer: A. Interlaced scanning. Explanation: interlaced scanning method is employed in analog television systems. It displays and transmits images on a screen or through a video signal. It was commonly used in older cathode ray tube, CRT, televisions and some older video formats. 57. Which scanning method only displays half of the lines at once? A. Interlaced scanning. B. Progressive scanning. C. Both A and B. D. None of the above mentioned. Answer: A. Interlaced scanning. Explanation: interlaced scanning method only displays half of the lines at once. 58. A screen contains more pixels while the displayed image has less detail. A. True. B. False. Answer: B. False. Explanation: the more pixels a screen contains while the displayed image, the more detail and clarity. 59. The color information in the video stream is represented by A. Luminance. B. Synchronization signals. C. Chrominance. D. None of the above mentioned. Answer: C. Chrominance. Explanation: the color information in the video stream is represented by chrominance. Color is made up of two primary components in color theory, luminance and chrominance. The luminance of the color is referred to as luminance, while the hue and saturation are referred to as chrominance. 60. The overall intensity or grayscale values of a picture are determined by A. Luminance. B. Synchronization signals. C. Chrominance. D. All of the above mentioned. Answer: A. Luminance. Explanation: the overall intensity or grayscale values of a picture are determined by luminance. It refers to a color's brightness or intensity. It denotes the quantity of light emitted or reflected by a color. Luminance is a fundamental feature of color perception and plays a significant part in designing contrast and visual hierarchy.